Coming up on This Week in Enterprise Tech, is net neutrality dead? And the IPv6 versus IPv4 brawl for it all. Twiet on the set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twiet. This Week in Enterprise Tech, Episode 66, recorded November 11th, 2013. IPv6 versus IPv4. This Week in Enterprise Tech is brought to you by GoToMeeting with HD Faces by Citrix, the powerfully simple way to meet with coworkers and clients from anywhere. Share the same screen and see each other face-to-face with HD video conferencing, even present from an iPad. Try it free for 30 days, no credit card required to get started. Visit GoToMeeting.com, click on the Try It Free button, and use promo code ENTERPRISE. And by RingCentral. We do everything in the cloud. That's why I love my cloud-based phone system by RingCentral. Zero startup costs, and RingCentral is $20 per month per user. Try it now with a 30-day risk-free trial and buy one desk phone and get a second phone free, up to 20 phones. Call 800-543-9980 or visit ringcentral.com and use our promo code TWIT. And by TechServe. TechServe assists U.S. businesses of all sizes with their technology needs, including Apple, Avid, Adobe, and HP solutions. Visit techserve.com/Twiet and receive a complimentary iPad deployment assessment. Welcome to Twiet, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Ballecer, the digital Jesuit, your guide to all things in the enterprise. But of course, I'm not guiding you by myself. I've got an all-star studded cast, starting with my good friend, Mr. Brian Chi, the geek in paradise, who is not at his hollowed-out volcano. Where are you right now, Brian?
Actually, I am enjoying Veterans Day, and I encourage everybody to stop and think. Not only are the people in uniform that have given service to the country, but there's quite a few people that are not in uniform that have put themselves in harm's way. Just think about the CIA, that wall of black stars. Those people have given up their lives to help protect our way of life. So pause a second and say thank you to those types of people too.
Absolutely. If you have a chance to see someone who serves the public, why not take today to say thanks? Let's go over to someone else I say thanks to all the time, and that is my good friend on the right coast, Mr. Curtis Franklin from Enterprise Efficiency. Curtis, thanks for coming back. It's always a pleasure to have you.
Padre, it's wonderful to be here on Twiet, as always. Glad to be there. It's a cool and going to get cooler day in Florida. We got the first big cold front of the year coming down. They say that on Wednesday, the high's only supposed to be in the 50s. And man, oh man, the mucklucks are out with the board shorts.
I don't think I want to know what that is. But you know what? I do want to know what it is. That's not, we use words. I do want to know what we're doing with net neutrality. That's our first big enterprise bite. Now, Brian, just for the folks at home, what is net neutrality? Just really quickly, what is your definition of what net neutrality means?
A network with a pH neutral. Oh, sorry, you're wrong. Net neutrality. No. It's in my mind. It's basically there are pools of people that can do their thing, connect to the network and have all this stuff, but not be technically under the thumb of, say, the ICANN and things like that. I don't know, man. There's a lot of different definitions, and you caught me a little by surprise with that question.
That's what I do.
Net neutrality really is exactly what it sounds like. Just try and get away from one entity controlling it.
Right.
Brazil and a lot of the other countries out there really don't like the U.S. having quote ultimate control of the network, and they'd like to make a change to that.
Curtis, what about you? What would be your definition of net neutrality?
Well, I think for me, net neutrality comes down to a simple concept. Bits is bits. Doesn't make any difference where the bits originate, what kind of traffic they are carrying, which ISP was the originating point into the internet, or for that matter, which ISP is the final point in the chain before it gets to a server somewhere. Bits is bits. It's a great concept, and so far it's worked really well to make sure that all traffic is essentially treated the same. And I think for the enterprise, where the net neutrality issues could become critical, are if it's decided by the various players who want to make an internet where some bits are more equal than others, have their way, then that means that someone is deciding which are the privileged bits. In some cases, it may be based on geographic location. Some countries will want to do that. Brian mentioned Brazil being one in particular. It may be content. We all know that deep packet sniffing does go on and content matters. Political statements could be decided to be less privileged bits, or it could be the type of content, the media type. We all know that video, for example, takes up huge amounts of bandwidth, and it could be that there are ISPs who decide that unless you are getting your video from their servers, that your video content needs to get a slightly lower priority, making for poorer performance. And that can matter if you're using a lot of video conferencing or video training for your enterprise. The idea that all bits are the same has served us really well, so well, in fact, that there are an awful lot of organizations, be they political or commercial, who have a vested interest in seeing that it comes to an end.
Right. I like the fact that I got two different definitions from my two different co-hosts, because that's exactly what we're trying to point out, which is net neutrality is one of these things that I think most of us say is a good thing, but I don't know if we all agree on the definition. For many, like Curtis, net neutrality means bits is bits. If I pay for my service, if my provider pays for their service, if the service that I'm trying to get also pays for their connectivity to this utility, this local pipe, my bits should flow unimpeded. For other people, net neutrality is, as Chibert mentioned, more of a power struggle thing. Who actually controls what happens on the net? But I bring this up because our first Enterprise Byte is all about this idea that we might be losing net neutrality. Now, back in the day, the telcos, you may remember this if you were hanging around the internet back at the start of TWIT, declared that it's time for these organizations like Yahoo and Google to stop getting a free ride. They actually said they're getting a free ride. They're saying they should pay to use our utility. This was despite the fact that they already were paying. So back in the day when I was trying to access Google, I had paid a normally exorbitant access fee to get onto, say, Comcast network. And Google was also paying an exorbitant fee to get pipes into that common tiered network. So they were essentially saying, we want you to pay again. We don't want just the customer to pay for the bit. We don't just want the provider to pay for the bit, but we want the provider to pay to make sure that nothing happens to the bit on its way over to the customer. That was where this whole thing of net neutrality really exploded. And it's become, well, granted that networks are going to be neutral. However, we've seen ourselves creep away from that over the years. Back in 2010, the FCC passed the Telecommunications Act, the Net Neutrality Act, essentially saying, look, you can't prioritize your traffic over the traffic of others just because you want to sell the service. Now it seems as if the Circuit Court in Washington, D.C., which is, by the way, the most powerful court in the land behind the U.S. Supreme Court, is ready to strike down that 2010 Net Neutrality Act. My question about all of this is, first of all, to Brian, we talk about net neutrality, we talk about losing net neutrality, but did net neutrality ever really exist? I mean, I know we've got this idea that the internet is this free thing where we all exchange ideas and we're happy, but at its core, when we're talking about a network, you have to manage a network, and any managed network is not neutral, right?
Yeah, well, I guess the internet too is probably the best example I can make. The research and academic institutions paid an amazing amount of money, including National Science Foundation money, because they demonstrated a distinct need for lower latency. So does that make their bits more important because they've paid for some dedicated pipes? Maybe. I know Ford Aerospace does the same thing. In fact, Ford Aerospace is now also on the internet too, as are a lot of other quasi-research organizations. So did we have true net neutrality? No, not really. We had varying levels of net neutrality. And we actually, when I first met Brandon, actually, one of his roles was to actually be hired by large corporations to tweak the network, to make it better, to work the social engineering so that the internet routing cross connects were more advantageous to the corporation. So no, we never really had true net neutrality, because if you wanted to pay, you could get better connections, faster connections, more efficient connections. But it was kind of close, and it was kind of the idealist view of the world, and I liked it. It was pretty good.
Yeah. Curtis, let me go over to you, because I think there's a specific enterprise angle that we can take on this, and that is enterprises are used to SLAs. If you're going to be doing business on the internet, you need a service level agreement. You need a contract with your provider to say, I'm going to give you this much money, and in turn, you are going to guarantee me certain metrics, bandwidth, latency, whatever it might be. So in that sense, we have a long history of paying for net neutral service. Now, what does this mean to the enterprise? If enterprise is already used to a tiered internet where you pay more to make sure your bits get to go where they need to go more quickly than others, then even if we struck down the 2010 Net Neutrality Act and the FCC essentially becomes an impotent entity to regulate what goes on in the internet, is that a good thing or a bad thing for the enterprise?
Well, let's start playing with some cases, because some of the SLAs, especially as they deal with the internet, they're very carefully defined in terms of what points are measured, because everyone recognizes that it is almost impossible to do any sort of performance guarantee on an end-to-end basis if you're using commodity internet. There are just too many steps and too many places that you don't control where a delay can be put in by weather, by technical problems, by other things. But you take some averages and you use those in your SLAs, and everything works out pretty well. What if, let's say you're a company that has put a lot of customer service agents out in remote locations, customer service agents in home offices, for example. Now, you might get some of those customer service agents who live in areas where the ISP that serves them locally, let's say it's their local cable company or their local telco, has decided that it's going to look at voice over IP traffic and say, you know what? Voice over IP really needs some privileged access, and boy, howdy, that costs extra. So if it's voice over IP traffic, we're going to tariff that at 3 times what we charge for just normal, say, email or text messaging. Well, now suddenly you and your service provider have to look at either some greatly variable cost or greatly variable performance, maybe both of those, in order to make sure that all of your customer service agents have roughly equivalent behavior and performance at their workstations. That's the kind of thing that we really open up to, watching these costs swing for different types of service that's being provided, and things that are beyond your direct control having an influence that is outside the normal statistical averages. It's really a place where, unless you are one of these entertainment companies looking to fatten its bankroll, this introduces all kinds of uncertainties and almost certainly additional costs that you as an enterprise aren't looking forward to.
All right. Cheebert, let me go back over to you, because we're trying to talk in reasonable tones here. We're saying, okay, look, there's always been network management. Of course, you have to prioritize some traffic over others. Yes, of course, enterprises, businesses can pay for an SLA where they get a guarantee that their traffic will receive a certain level of attention versus, say, Joe Schmo with a modem, a 56K modem dial-up connection. However, I don't think we're talking about that when we talk about the threat of losing net neutrality. We're not talking about the regular network management stuff. I think we're talking about the more insidious stuff that could be happening within the telcos. For example, let me take a very common example, Comcast. Comcast is not just a telco. They do not just provide internet service. They actually provide content. More than that, they sell content. They're a content provider and a content delivery system. With a nightmare scenario of the 2010 Act gone with, Comcast could foreseeably, and we know that they've been testing this, say, look, sure you can get Netflix if you're a Comcast customer. Sure you can get Hulu. Sure you can get Amazon Prime Video. But their video might suffer. Their packets might get a little delayed because they're coming from off of our network, and we deliver all the packets on our network first. That's really the scenario that I think people are afraid of when they talk about the loss of net neutrality, yes?
Yes, indeed. In fact, it's not might, it has happened. When Oliver and I were fussing around, I was trying to optimize his home, we found out very, very quickly that certain services, at least for a little while, just flat out didn't work. We ended up actually having to play around with some really goofy proxies in order to get those services working at his home. So it has already happened. I know Comcast has backed off on that, but Comcast is also famous for not allowing any kind of incoming web services. They're already starting to differentiate. They say, if you want incoming web services, you're going to have to pay more. And if that web service is hosted in a Comcast data center, it'll work better than if you're running it, say, just a pipe. So it's already starting to happen. And so net neutrality doesn't sound quite so bad because it would prevent clowns like this. I hate the fact that Comcast is saying, gee, me first. But at the same time, blocking the entrance into markets by other competitors. It'd be great if Time Warner could come in or Comcast could come in. That way people could have a choice. But in many, many areas around the United States, in fact, many, many areas around the world, you have one and one only choice on internet service provider for that last mile. Personally, I think the one piece about net neutrality that's pretty good is it's already starting to try and make it so that other carriers must be given the same opportunity to run the fiber optics or coax on the poles or in the conduits, so that a consumer has a choice.
Right.
So that part of net neutrality I really like. I just don't really quite agree with how heavy-handed some of the net neutrality rules have been in the past.
Curtis, let me go back over to you. Let me give a balanced view, because I don't want it to sound as if I'm just hating on all telcos and saying, oh, they're all bad people twirling their mustaches. There's also the little problem that we have right now where the telcos are complaining that they're still under these incredibly restrictive rules that the FCC created for them years and years and generations ago. And then you have a carrier like Comcast, which technically can't really be touched by the FCC. You can't regulate a Comcast like you regulate a Verizon or an AT&T because it doesn't fit into the definition of a traditional telco. We've got this dichotomy of services where some companies are regulated, some others are not. And so you can actually make an argument that, yeah, we need to lift the draconian restrictions. We need to find out exactly how this new generation is going to work. We need to find out how we're going to get more carriers into more areas so people actually have a choice. But if we do that, my question to you is the only real alternative to say, oh, well, the carriers have to police themselves? I should note that if you're watching live right now, there's a great debate going on in the chat room. One of our guests, Carl Auerbach, is in there right now and going back and forth about, well, do we need another ICANN for the internet, for net neutrality? No, we don't. Yes, we do. Tell me, what's your take?
Well, Padre, I think that, as is so often the case, you've hit the nail on the head when it comes to this debate, because the real secret is trying to find a way to not discourage innovation, to allow and even encourage innovation, while at the same time we protect the right of individuals and companies to get their data. It is a nasty balancing act that has to be accomplished here. So far, we really have come down on the side of some of the very old line telecom qualities and virtues. I remember a telecom engineer years and years ago when I was first starting to cover the industry. He slammed his palms down on the table and said, the first law is you don't mess with the dial tone. He was a little
I'm sure
he
said mess with. I believe I remember that from historical documents.
Trying to keep this family friendly here. But in a lot of cases, we really are erring on the side of caution. And I'm not sure that's a bad thing. You know, telcos were traditionally monopolies. They still are in many cases. Telcos have the ability to control lines, and we require people to have telephone lines, in a way that we don't require them to have cable television. Now, all of this is in flux. All of this is dynamic. And the problem is that these telcos, all these companies that are involved in carrying traffic, are squeezed for profits by their shareholders. So they are very naturally going to maximize profit every chance they get. If the net neutrality rules are relaxed, it is certain that we're going to see certain types of data that are disadvantaged unless the people providing that kind of data give extra money to the telcos or the cable companies.
Well, Brian, Curtis, thank both of you for that discussion. I do want to come back to it, but you know what? I think maybe our super special guest might have something to add to that conversation. But before we get to that, before we get to the IPv6 versus IPv4 brawl for it all, let's take some time to welcome our first sponsor. Now, you know them, you'll love them because they've been with us for the longest time. They are GoToMeeting with HD Faces by Citrix. We know that you need to have meetings. It's how you communicate. It's how you succeed. It's how you stay on the same pages. Meetings are absolutely essential to making your enterprise a success, but we know also that not all meetings can be planned in advance. Work emergencies have to be handled. Inspiration strikes at odd times. Unexpected opportunities present themselves, and you have to be ready to pounce. With people working from different offices or on the go, it can be impossible to get people into the same room for those essential meetings, which is why we want you to be prepared by signing up for GoToMeeting. It's a powerfully simple way to meet and collaborate online wherever you need to, wherever you are. Now, with GoToMeeting by Citrix, you can share screens to work together on documents, spreadsheets, and projects in real time. And turning on your webcam turns your meeting into a group HD video conference. It's just like meeting in person. You get to see their face. You get to see that frown. You get to see the raised eyebrow that tells you that, yes, they have it, or no, I need to explore more. And Citrix understands that the meeting needs to be the focus of your time, not the tech. So they make sure that it's easy to set up a meeting. If you can click, if you can send an email, you can set up a GoToMeeting. And you can run it from any Mac, any PC, smartphone, or tablet. I'm not just a spokesperson for GoToMeeting. I actually use it. I'm a customer. You see, my work has me meeting with literally hundreds of coworkers and colleagues each month. I used to jump into a plane every time I had a meeting because that was the accepted way of getting face-to-face time. But it was just too much travel, too much downtime. I switched to GoToMeeting with HD Faces, and I haven't looked back. Not only did it cut my travel time in half, but it allowed me to have more interaction with the people that I needed to collaborate with the most. It saved my organization money. It saved me time and wear and tear on my body. I love GoToMeeting. It's so easy to use, and with HD Faces, it's just like meeting in person. So here's what I'd like you to do. I want you to start hosting a GoToMeeting in seconds from your computer or mobile device by signing up for a free, that's free, gratis, 30-day trial. There's no credit card required to get started. Visit GoToMeeting.com, click the Try It Free button, and use the promo code ENTERPRISE. That's GoToMeeting.com, promo code ENTERPRISE. But wait, that's not all. We have a winner. That's right, last week we told you about a little contest that GoToMeeting was holding. They wanted to know where you would hold a GoToMeeting, and they wanted to know who you would hold it with. We asked you to tweet out with GoToMeeting and the hashtag WinEnterprise, and now we have a winner of a $300 Apple gift card. Thank you to everyone who tweeted in pictures of where in the world they would host their ideal GoToMeeting. I am pleased to announce the winner of the Apple gift card, value at $300, is Brandon Takamori. He tweeted a picture of the Go-Go Curry House in Tokyo with the hashtag WinEnterprise, tweeted at GoToMeeting. Congratulations to Brandon. Enjoy that gift card, and don't forget to try GoToMeeting free today. Now let's get to the great debate. We have two guests who are going to be taking either side of this IPv6 versus IPv4 brawl for it all. Let me start in-house with Mr. Carl Auerbach. He's really a man who needs no introduction because he's been here before. He's with Interworking Labs, and he is, well, I say probably one of the brightest people we've ever had on the show. Carl, thank you very much for being on the show, and thank you for being engaged with the chat room. I saw you writing back and forth. Welcome back. Tell the audience, maybe those who haven't seen you before on the show, who are you and what do you do?
Who am I? The great question you should ask everyone. I'm Carl Auerbach. I'm CTO of Interworking Labs. We're in Scotts Valley, California. In the grander scheme, I am an internet troublemaker. Been around since the beginning of the net in 1968. I was in the room next door, number one, working on a project where we were crashing cars. But I got on the net in the early 70s, working for one of the unmentionable agencies at Fort George Meade in Maryland on network security. TCP, the IP was split off from TCP on my blackboard at System Development Corporation in 1974. And I've been on the net ever since. I'm responsible for things like NetBIOS over TCP, so you can blame me for that.
Yes, I will blame you.
A lot of people
Actually,
should.
no, I won't blame you because I remember in the early days I used those protocols to a lot of fun. Only the old people will understand that. Let's get our second guest in here, who was supposed to be in studio, but he got called away at the last minute to do some work in Colombia, in Cartagena. Mr. Brandon Ross. Brandon, thank you for coming on. We are longtime colleagues at Interop, and where are you again? You're in Colombia somewhere, yeah?
That's right. That's right. You had it right, Cartagena.
Okay, Cartagena. And I know you work for you run Network Utility Force. You have a long history of jumping from company to company as they need a routing specialist. That is your forte. If it has to do with routing, it has to do with IP, you're there. Now, tell us a little bit about your bona fides. What do you think the Twiat Riot needs to know about who you are?
Sure, yeah. The Carl's introduction is a tough act to follow. Carl is a pretty impressive guy, but I am the chief network architect and the CEO of Network Utility Force. And like you said, we are a firm that specializes in helping companies build network infrastructure, especially big architectures. So we work a lot with service providers. We work a lot with enterprise as well, solving these kind of big scalability and maintainability problems with networks.
Yes. I remember a few years back when I first started working with Interop, I sat down with you and you turned to me with a issue that you were trying to resolve, and you just let go with this long stream of words, which started with IPv, and then I lost you. And I remember that's when I realized, okay, I need to learn from this guy. Now, I have brought the two of you onto the show because we want to have the IPv4 versus IPv6 brawl for it all. And of course, that's link bait. It's not really a brawl. You're not going to say, oh, I hate this, I hate that. But you do have competing visions of where the internet is headed. Let me start with you, Brandon. You've been a big proponent of IPv6. You've been there with the standard getting delayed and getting delayed and getting delayed. We're starting to see more and more equipment that's a dual stack. We're starting to see more equipment that's actually using their IPv6 addresses. What do you see for the future of routing, especially with IPv6?
Yeah, so the future was very unclear, and to anticipate maybe what Carl might be saying, until the last few years. And maybe, I don't think we need to give a whole lot of background on IPv6, but maybe I should start with just a little bit, just so folks know exactly what we're talking about. So as probably all of you know, IPv4 is the essentially original protocol that most of us are used to dealing with on the internet. Sure, there was a couple of precursors to that Carl knows a heck of a lot better than we do. But most of the growth of the internet by far has been on IPv4, the version 4 of the IP protocol. IPv6 was built kind of as a new vision of the IP protocol and added a bunch of features and functionality besides just a much larger address. to fix some of the problems that we experienced originally with IPv4. But most of those features and functionality items have been backported into IPv4. So the debate today is not really any longer about whether the extra security or extra functionality features that are available on IPv6 are important. What's really important today is the size of the address space and the functionality of using IPv6 as we run out of IPv4 addresses.
Right, and of course we're talking about IPv4 address exhaustion. Any of you who were networking back in the 90s will remember when we hit that point of panic when people were saying, oh, we're allocating all our addresses. And just recently, we actually did hand out the last block of IPv4 addresses. It was a big problem way back in the day, but Carl, this is where I'm going to cut over to you. We needed IPv6 back when we realized, oh, we're going to run out of addresses. But then this wonderful thing came along called NAT. You want to talk a little bit about that?
Well, the first thing I wanted to mention was there's a really interesting story, which may not be quite maybe the wrong color to be on the air here, about some of the first equations of when we were going to run out of IPv4 addresses. Let's just say they were performed on the back of a napkin at a strip joint at a Vancouver IETF. It's been a long time coming, and IPv6 is better than IPv4. I wish we had had it in the early 80s and never had IPv4. We would have been just much better off. I'm thinking of, there's really no distinction between which is better, driving on the left side of the road or driving on the right side of the road. It's a choice. It's the conversion's hard. There's an old joke about in Sweden when they switched, that on Monday they switched to large trucks and on Tuesday they switched the remaining automobiles. The problem with IPv6 is not IPv6. It's fine. It's perfect. It's great. In answer to your question, however, I don't see that makes a lot of difference about large-scale routing. We're still moving around BGP lists of ASNs, whether it's IPv6 or IPv4. The real issue is the conversion. There's just a lot of equipment out there. It's going to be very expensive to move. And my issue is not IPv6 versus IPv4. It's, is there another way forward that may make IPv6 not necessary to switch to, or that we could switch to it in pieces?
Okay, Carl, wait. I'm going to hold you to that. I like that. Is there another way forward? I think we could use that as our first major question. What would you say is the way forward? If we're not using IPv6, if we're not going to an address scheme that could give an IP address to every atom and grain of sand in the universe, whatever that's going to be, what do we do?
Well, I'm a person who strongly believes in the end-to-end principle. Every interface with an IP address should be able to talk to every other interface in the world, universe, whatever, with an IP address. I would prefer that. I strongly believe in the end-to-end principle. However, as a pragmatic person, I think that we very well may end up with a network which, as I described in the previous show, an island and bridge networks in which we simply cookie cutter out replicas of IPv4, IPv6 networks, each with its own complete address space, connected by engineered bridges between them. And the reason I say that is because I'm just one of the few remaining people who believes in end-to-end principle, but most people these days seem to care about whether their applications work without caring anything about the plumbing underneath, whether it be NATs or, as my suggest, application level gateways, or carrier pigeons. Doesn't really matter. They don't see it, they don't really care.
Brandon, let me go over to you. That's actually a really good point. IPv6 has been proposed by people who want to keep that end-to-end principle. Every device on the internet should be able to talk to every other device on the internet. It's the Internet of Things, right? We start adding sensors to everything. We need enough addressing space for all those new devices. But what if we carve off IPv4 addresses? We create new IPv4, new IPv6 networks that can be closed off by geopolitical boundaries. Isn't that a better way of looking at it because it actually reflects the way the world works?
Well, that's kind of the point that I was about to make. And first of all, we're all in violent agreement that the end-to-end principle is better. But I think it's not really an IPv6 specific subject or specific problem, right? If you look at just the IPv4 internet today, you'll notice that there are geographies and political regimes that have restricted even the IPv4 communications within their countries or within their their managed areas. Now, are those application level gateways today? Not necessarily, but I don't think that's the technical pieces of that are the important part. I think the important part is, do you really have an end-to-end principle in effect on IPv4 today? And the answer is no, but, and this is the main point that I really wanted to make, those are a relatively small part of the global IPv4 network. And while, and in some ways I agree with Carl in that I believe we will continue to see that with IPv6 as well, but I don't think it's going to grow. I think that we're going to find that hopefully we'll end up with more end-to-end communications throughout the internet as some of these regimes liberalize. But that's really at the political level as opposed to the IPv6 transition level, which is a completely different conversation, which I think Carl is kind of integrating those two points at the same time. And I tend to feel that they're really different points and different concepts that are somewhat independent of each other, but not completely decoupled.
I like that. Okay, so let me do a little bit of read back for you, Brandon. Essentially what you're telling me is, look, yeah, we understand that there are geopolitical distinctions, they're endpoints within networks that certain companies, certain regimes have tried to use in order to protect their citizens, to moderate what their citizens see, whatever, however you're going to look at it, however you're going to call it. But you're also saying IPv6 it makes more sense because those political boundaries aren't always going to be there. We're going to see a shifting, we're going to see liberalization, we're going to see networks that get to be more flat, and IPv6 is the perfect addressing scheme to use for that.
Yeah, essentially that's what I'm saying. Exactly right. Now, we are going to see, for technical reasons, some regionality where you have islands of different kinds of connectivity, but that's not necessarily because of geopolitical reasons. That's because of practical and cost reasons like Carl was referring to. But I believe that those are very temporary. The example would be, pick your local hometown ISP. As a matter of fact, my company, we just did some work for a small service provider on the East Coast of the United States that had this very problem. They're running out of IPv4 addresses. They're not quite ready to invest in the upgrade to IPv6, which I think is what Carl's point is. And so now they will have this small island of NAT44 between their broadband customers and the rest of the internet. But we are already talking to them about upgrading to native IPv6, at least in the parts of their network where they can. And so, like I said, I believe this is a temporary situation where we'll see some of that divisions. But I think at the IPv6 level, for the most part, people will be truly end-to-end without NATs or anything like that in between, except, again, for geopolitical reasons in the long run.
All right. Well, let me throw that back over to Carl. So, Carl, is the need for these I'm going to call them countrywide NATs, the separation of the internet into multiple internets that still have a modicum of end-to-end principle because you can get from one gateway into another gateway. Is it just, as Brandon said, a temporary thing? Are we looking at this the wrong way? Are we designing a network after a changing geopolitical facade where we should be designing it for the unchanging network underneath it?
Well, there are so many points of agreement between Brandon and myself that we could go a long way there. A couple things. The driving forces are not just governments doing bad things to their or good things to their populations. We have companies that want to spy on data, Google, Facebook, whatever, to sell that data. They like the islands and bridges because it creates very nice places to inject. We have that NSA diagram that was on the front pages of the newspapers today, showing that these points of exchange are great places to insert spying. Yeah, that's the picture right there. That thing GFE in the middle with the smiling thing from the NSA in the bottom. There are driving forces to create a network which has very explicit exchange points, and it's not just governments doing it. There's some issues that are also in play here, which we haven't gotten into, is that IPv4 is relatively mature, yet the implementations still are really bad. They're held together with duct tape and baling wire. My company tests things. We see this all the time. We recently tested a major vendor, and I mean major vendor of IPv6 code, and they had passed the IPv6 logo ready thing and had all the stickers and everything else. We found lots and lots of problems.
Okay, wait. I can't let you get away with that. What were the problems that you found?
Oh, things like checksums.
Oh, okay, that's pretty basic.
Why do we still have this crummy one's complement IP checksum? Why didn't we use the Fletcher checksum that OSI had? Much better. But nevertheless, in the world of where you have pieces of fragments of packets, which do happen in IPv6, routes do change, your MTUs do change. there were reassembly problems. Apparently, there's some problems with the pseudo header calculations in TCP and UDP in various stacks, because a lot of the application people didn't realize that some parts of TCP and UDP did have to change when IPv6 addresses were involved. Basically, IPv6 implementations are immature, and we're going to go through a period in which we're stepping backwards, and things that did work on IPv4 no longer work. There was a recent publication, I think by Verizon or T-Mobile or somebody, who just did a run-through of major applications, and things like Netflix did not work on IPv6. It was pretty scary that people just have not been testing very well. They've been testing in laboratory conditions where they're testing basically if you imagine an automobile going down the center of the lane and it works great. But in California here, we have these bumps, little bot dots between lanes so you can feel them. Well, imagine if your car has been tested only in the lanes, but if you hit a bot dot, your wheels fall off. Well, that's what we're seeing we've seen that in IPv4, but we see it even worse in IPv6 implementations, is that the code bases are weaker because they have not been subjected to stressful conditions yet. So there's going to be a period which, even if we go through these transitions, which we're going to have a setback. We're going to have a Obamacare website problem kind of thing in lack of testing hitting us with IPv6, just because it's new code. Even if it's better, it's new code.
All right, so let me do a readback for you as well. I understand, so one of your contentions is that IPv6 just isn't quite ready for prime time yet. It's been priming for a really, really long time, but you're finding, well, problems with it that really shouldn't be there after such a long development time. But I do want to go back to the original question, which is why IPv4? I mean, yes, okay, maybe it's more mature, but when we go back to the question you first proposed to this panel, which is what's the better way to do it? Why would I go with IPv4 versus IPv6, putting aside for a second maybe some of the immaturity of the standard?
I personally would like to go to IPv6, for example. At my home, I'm on Comcast. They're a big promoter of IPv6. It would cost me $250 to buy a new box. It would cost me basically rip out the old one, reprovision the new one with no real help from Comcast. And I'm a techie, and I look at that and say, okay, I'm going to knock out my telephone service and everything else while this is happening, and I don't necessarily have a backup path. Well, I might be willing to undergo that process, but how many other people are willing to undergo that process?
Okay, yeah,
go ahead, Brandon.
Brandon, get in here.
And I was going to say, on the other hand, I'm also a Comcast customer. And in my case, though, it was the exact opposite. In my case, I woke up one day and said, hey, you know what? I wonder if I have IPv6 enabled here yet, but I hadn't yet actually poked at my own AP, my own home router to see if it had been if I had actually ever turned it on, and I didn't. I changed one setting on it, and boom, I have native IPv6 in my house. Had it for about a year. Absolutely no interaction with Comcast was necessary. It was just on one day, and then that was it. So I think these things can be done. I definitely agree with you that V6 is as a protocol and not so much as a protocol, but although there are weaknesses there, but more on the stack side is definitely not mature yet. But I would also counter argue and say that I don't think we understand application level gatewaying at that scale well enough to be able to deploy that either at a country level scale. I think we'd find at least as many problems, if not more, in trying to build something like that as we do with the IPv6 stack.
Well, I think we have a better chance of success with application-level gateways than with NATs. I mean, NATs to me seems to be a dead-end technology, whether you call it carrier-grade or not. There's only 16 bits of port space, and squeezing information through that is just troublesome. Most modern,
right, but that's why I think that the NAT is a temporary solution as well.
I think it's a very temporary solution. But we're seeing proxies go, proxy being my other word for application-level gateway. Modern protocols tend to be designed to work through proxies. They have fewer visible or apparent problems because we're not trying to squeeze them as hard. They're easier to load balance between them, that sort of thing. That's why I always try to differentiate that. I'm not an advocate of a NAT. I'm not even an advocate of application-level gateways. I'm just saying this is a path which those who prefer a fragmented or lumpy network might choose to follow rather than switching to IPv6, or they might choose to deploy IPv6, but in a separate 128-bit address space.
We're going to come right back, and when we do come back, we're going to be bringing in our other two co-hosts. And Brian actually reminds me that NTT Japan is 100% IPv6. They've actually removed all their IPv4 addresses. But before we get back into the brawl for it all, I want to talk about the second sponsor of the Twilight Right, and of course, that is RingCentral. Now, you've heard it before because we are such a big fan of RingCentral that when Leo built this brick house, he decided that we were going to dog food. We had been telling people forever that they should put more and more of their services into the cloud, that they should trust the internet. That's why our scheduling is in the internet. That's why our documents are in the cloud. That's why all of our email is done in the cloud. So when Russell, our IT guy, came to us and told us that we could have a full-featured phone system without having to have a clunky PBX in the basement, well, it was a no-brainer. We love RingCentral. Zero startup costs, no PBX hardware to install or maintain. RingCentral allows us to easily customize all of our call handling. Our producers can get their voicemails through their emails, and we can even get our fax messages right on our smartphones. RingCentral will also give you your own auto receptionist. You can greet your callers, announce employees, and department extensions. Getting calls after hours? No problem. RingCentral will route your calls to your smartphone's phone service center or voicemail. Have clients on hold? You can type a message in real time and have it translated from text to speech and delivered to your caller while they wait. So RingCentral makes it easy for you to set up. See, they offer all-inclusive pricing as low as $20 per month per user. Essentially, if you have an internet connection and a desire to have phone service, RingCentral is for you. You can start right now with a 30-day risk-free trial, and they have a special offer for my listeners. When you buy one desk phone, you get a second phone free, up to 20 phones. So call this number, designated for my listeners, 800-543-9980. That's 800-543-9980. One more time, just in case you're coming over an IPv6 network, 800-543-9980. Or you can go to ringcentral.com and use the promo code TWIT. That's ringcentral.com, promo code TWIT. And we thank RingCentral for their support of This Week in Enterprise Tech. Now, let's get back to it. I do want to bring Brian and Curtis back into discussion. Brian, you have also been doing a lot of IPv6 work because you work at a university. So, of course, you deal with a large network, and, of course, you've dealt with internet, too. How does this debate strike you so far? We've got Brandon, who is saying, look, all of our gear is coming out with IPv6. It's a more logical solution. You've got Carl, who's saying, IPv6 really isn't ready for prime time just yet. IPv4 is much more mature. We can get away with IPv4 right now. Why would we make the switch?
Okay, so first and foremost, the market is what needs to drive this. You know, I'm a big supporter of vote with your dollars. And a lot of firewall vendors, a lot of print server vendors, a lot of, webcam vendors say, okay, I had to implement IPv6 because the Department of Defense says they won't buy from me unless I have IPv6, but nobody's using it. So why am I going to throw money into development to make it better, to make it more usable? Even though the University of Hawaii is a very major IPv6 supporter, we actually don't even have DHCP v6 yet, which is kind of one of the really big pieces. Slack is great. Slack is an automated router-based configuration tool, but what it does for things like voice over IP, this is coming from the InterruptNet experience, we actually had to get DHCP from IPv4, get the information on where the IPv6 piece for VoIP needed to go, reboot, and then finally get the IPv6 running. It was kind of cumbersome. And until more of the vendors start saying, hey, V6 is part of our mainstream code, it's going to work, we're going to make it work, we're going to spend money on making it cleaner and easier, we're actually going to put it in the GUI instead of forcing you to do the configuration in the command line, the general consumer isn't going to want to do this. It's still too complicated. And I'll tell you right now, the number of print servers that have IPv6 support is still relatively low. HP has made a pretty big concerted effort to do it. So is Xerox. But a lot of the third-party, the cheapy print servers, still don't talk v4. A lot of the small firewalls do v6 kind of. A lot of webcams do v6 kind of. The consumer products need to step up, basically, and then we might start seeing v6 happen.
Right. Curtis, let me go over to you, because we have seen an increase in the number of equipment that can handle IPv6, but it seems as if that number rises only with the standard replacement of equipment. In other words, if you buy an enterprise piece of gear today, it's going to have IPv6 enabled. But that doesn't necessarily mean they're using IPv6. Most enterprises that I've worked with, they'll dual stack. They will have an IPv6 address assigned to any piece of equipment, but their IT people are still far more accustomed to working with IPv4 versus IPv6. At this time, from an executive, enterprise executive level, do you think they're making a conscious decision to buy enterprise gear and replace their own gear? Or are we just talking about the standard revolving of old gear out and the acquisition of new gear?
I have not heard any executives say that IPv6 is driving any equipment purchase. So I think what we're seeing now is standard replacement cycle, standard gear rev cycle, people adding IPv6 capability as the new gear comes in. But I don't think I have heard anyone, certainly in North America or even in Europe, say, you know what, we looked at what was happening and decided that we needed to move our replacement cycle up by 1 year, 2 years, in order to be fully IPv6 compliant this month. It's just not happening. Dual stacking is still working for a lot of companies. There's no requirement to move. And hey, let's remember, there are still enterprises out there who are in the process of moving off of Windows XP. They're not going to jump at something like this unless they're absolutely forced to.
Right. Brandon, let me throw this back over to you. What do you think about what you've heard from our co-host? First of all, that we're not seeing this adoption in consumer level anymore. And that used to not be an issue, but with the BYOD trend, you're seeing more and more technology make its appearance first in the consumer level and then move up to the enterprise. The second thing is about that adoption number. If the increase of IPv6 capable gear in the data center, in the data closet, in the local networking plant is purely a function of gear replacement cycles, do we see this as a desire for IPv6, or is it just something that we only use if it dual stacks?
Yeah, so let's frame this conversation a little bit better. Like, one of the things that we're talking about here is what we're predicting is the long-term configuration of the internet, right? What we're saying is it going to be a bunch of islands and bridges like Carl is talking about? Is it going to be mostly end-to-end like I'm talking about? And so the near-term trend of whether people are demanding necessarily, especially enterprise customers, demanding IPv6 capabilities in their equipment or stepping up replacement cycles, particularly do IPv6, I don't think is completely relevant to that. But what I do think is important, and what I do think is worthy of watching, is that while at the higher levels we've run out of IPv4 space to subdelegate to the regional internet registries, we haven't really run out of available IPv4 space for growth yet. And so I don't think you're going to see a real inflection point in either deployment on IPv6 or in demand for IPv6 capable equipment until it actually becomes much more difficult and much more expensive to get IPv4 addresses. And then the third point I want to make about that is that we don't necessarily have to see end users demand this technology, because end users will never demand this technology because it's under the covers, right? It's like if you were driving your car and you demanded a different kind of asphalt for the road because you knew something about how the road works and you knew it would be better. Well, people don't do that. You drive on the road, as long as it's not bumpy, you're satisfied with it, right? It's the same thing for end users and what version of IP protocol they're using. They shouldn't have to know. It should just work. And I think you and I and other folks here have experienced that at Interop. How many thousands of people showed up at Interop over the last several years with their own devices on the Wi-Fi and used IPv6 and almost certainly never even knew they were doing it.
Right. Carl, let me throw that over to you, because Brandon makes some excellent points, especially about the part that maybe what we're missing is the true emergency. If right now we haven't actually exhausted IPv4. I mean, we've handed out all the addresses, but there are still IPv4 addresses in circulation. Most devices are still working. At some point, that's going to stop, right? And when it stops, are they going to go with the island and bridge scheme, or will they go with IPv6, which is already underlaying a lot of this gear? What would be your response to why we would go with island and bridge?
Well, I happen to be one who has public address space that I got way back in the dark ages, and so I see no shortage. I have my own. I operate a lending library where I hand out space for temporary use to people for free. I can't agree more with the notion that end users really don't care. They don't even know. I have no idea what my iPad here is talking over the wireless and whether it's IPv4 or IPv6, and I don't care. It works. But that's also because I don't care and the rest of people don't care, it opens up the opportunity for the future to evolve in different ways. And I don't know whether we're going to move to the island and bridge or to the IPv6 everywhere approach. I would prefer the IPv6 everywhere approach. But I've lived enough in the political world and also as an attorney that I see that technology is affected by so many forces. I'm reminded of the Hushaphone case from way back in the early 1950s when AT&T wanted to try to lock down the telephone world, and it made all of these representations about things, and the FCC backed them up. And it ended up that those representations were just too strongly made, and it ended up fracturing the telephone. That was what led to the AT&T breakup. I mean, the world is, we can't really tell where it's going to go, but my argument is it may not go the way we as technologists want it to go, because we are only one hand on the steering wheel and there's many other hands, and we need to recognize that they are pulling possibly in other directions than where we as technologists and principal technologists might want to go.
I want to throw that back over to you, Brandon, because those are great points. How would you respond to that? How would you respond to, one, that IPv4 is more mature, that two, IPv4 is less expensive for those who have to make that adoption, make that switch, maybe their gear's not dual stacked yet, and three, that the bridge island network is a better representation of any world. Maybe not necessarily that this current geopolitical situation is going to maintain, but that there will always be entities that want to carve off their own bit of the internet. Yes, we're all technologists, and so yes, we're all going to see IPv6 as a better solution, but I think we've already shown that the end user doesn't care as long as it works. And if IPv4 can be made to work, and if it can be more mature than IPv6, isn't that a viable option?
So we're in some violent agreement here. There will always be some islands, right? I'm not attempting to argue at all that there won't be islands. There will always be some islands. There'll always be North Koreas that want to be completely disconnected from the rest of the world, not just in IP, but in all aspects of society. Those places will always exist throughout time. So I'm not arguing for a second that that's not going to happen. What I'm arguing is that for the overwhelming majority of the internet, especially most of the Western world, that we're not going to see that level of proxying between either companies or governments or what it might be. But on the other hand, what I would argue, and what I have argued and will continue to argue, is that there is eventually a driver for customers to demand IPv6, although they may not know that that's what they're demanding. And that is, I believe strongly that our performance on an end-to-end IPv6 network is always going to be better than either NAT 4.4 or proxy connections. And I think that's just by nature of the underlying technology that bridging through something is always going to be less efficient. And so since that's less efficient, I think what we're going to see is that end users are going to demand something that doesn't have to be proxied, because proxies suck and NAT sucks. And so that's when I think you start seeing demand by end users and enterprises to fix that problem. So the scenario that I talk about a lot, I tell this to a lot of my enterprise customers, especially ones with large, web presences, whether it's a content company or a company that sells products across their website. If your website is only on IPv4 and a customer has to go through multiple NATs, or let's say multiple proxies to reach your website to purchase product. And that makes your website a few seconds slower to complete a purchase than the next website over who has enabled end-to-end IPv6. Who's that customer going to be more likely to buy products from? And that's where you start seeing the demand for equipment that's capable of end-to-end. And that's where you start seeing demand from upstream service providers and governments to stay out of the way so I can execute my e-commerce.
Let me go over to Curtis. Curtis, so would that be the way to sell this to a enterprise executive? To say, look, it's not about the gear. We're not buying this for IPv6. We're buying it because we want to provide the consumer with a better experience. We want our gear to run faster. We want our services to reply more quickly. Is that something that then becomes, yeah, we will spend money on that?
I think in many cases, the answer is yes. If you are a company that's providing a vital service over the internet, or for that matter, if you're selling your services or products over the internet, then you have a tangible reason to want to have your performance as good as possible. If IT can go in and say and show that IPv6 is a cost-effective way to make that happen, then it becomes an easy check for the executive suite to write. The problem comes when someone says, prove it. If you can do that, you're golden. If you have to say, well, you know, as the internet moves in this direction and more people do it and lots of it, the more times you have to add a verbal comma, the less likely it becomes that the executive suite is going to pull out its checkbook.
Cheever, the whole idea behind dual stacking was that we could use gear in IPv4 mode while creeping in IPv6, getting people used to having that option. When do you see the switchover happening? When do you see gear actually starting to drop out IPv4 addresses, either because they're exhausted or because they become too slow because they're using an island and bridge scheme? When is that point that they're going to be forced to make a decision about going with IPv6 or some other scheme?
You know, that's kind of like asking when, oh geez, when is the sun going to burn out? I don't know. There's a lot of factors that we're talking about here, but there are carrots and sticks coming out that are kind of interesting. Like, for instance, the guys at Penn State actually will live cast most of their home sporting events, but only on IPv6. So they're using a carrot and stick to try and get the Penn State populace to at least dual stack their machines. And more universities are doing this. And some of the new services coming out, keep in mind that Windows 8 and Windows Server 2012 are IPv6 native now. They will actually attempt to do a lot of connections over IPv6. And so we're already starting to see some of the carrot and stick happening. It's just that the consumers aren't noticing yet. And I'm not sure how that's going to change, but I keep hoping it'll change.
We're going to have last words from the Brawl for It All after these messages. But first, I want to take a moment to thank the last sponsor of this episode of This Week in Enterprise Tech. And of course, it's TechServe. You see, we are all about the enterprise, but sometimes we forget how big Apple has become in that enterprise solution. That's why I am pleased to welcome TechServe to the Twilight Riot. As New York's premier authorized Apple reseller, TechServe serves creative professionals at all levels, from individual customers to Fortune 100 companies. TechServe carries a full range of Apple products, from iPhones and iPads to iMacs, MacBooks, iPods, and accessories. TechServe also has a range of partnerships with top vendors to facilitate flexible, efficient, and creative solutions for all your business needs. TechServe assists businesses of all sizes to deploy Apple, Avid, and Adobe solutions throughout the United States. Whether you're already committed to iPads or just getting started, from sales to support, process to practice, TechServe can help. Now, some amazing technology solutions are already deployed on iPads, and I know that some of you have seen them. If you've been to the Delta terminals in LaGuardia, Toronto, or Minneapolis, you may have noticed nearly every seat in the terminal is equipped with an iPad. I actually took this footage a few months back because I landed and I saw these, and I was just astounded by how cool it was. It really did change the nature of the airport. Travelers can now sit anywhere in the terminal and receive real-time flight updates on the iPad, or use them to order food, play games, browse the internet, and check email while they're waiting. Over 1.5 million visitors use these iPads in Delta's terminals just this past year alone, and the result has been a double-digit increase in food and beverage revenue and the highest customer satisfaction scores of all participating airports. OTG Management, that's the hospitality company behind Delta Terminals, turned to TechServe to provide, configure, and install the world's largest deployment of iPads. It's a number that just keeps growing as they add new terminals. And TechServe really was the natural place to turn because they sell, support, personalize, configure, and manage massive iPad projects. It's what they do, from the Delta Terminals to a school with 700 chef instructors to an operation that delivered personally configured iPads to 3,000 cable technicians. TechServe is able to do full life cycle management for all your technology needs. What does that mean? It means that it's a turnkey solution. They provide the devices that you need. They get them up and running. They teach you and your staff how to efficiently use them, and they maintain them so that they're always working properly. TechServe also provides ongoing support so that if your enterprise has a problem, help is never further than a phone call away. If you're considering adding iPads to your business, why not ensure the project's success with the world's most experienced partner? Here's what I'd like you to do. If your business is considering integrating iOS technology at your workplace, then contact TechServe today and receive a complimentary iPad deployment assessment. Visit techserve.com/Twyett, and TechServe will help you assess your current or future iPad needs and give you advice on how to make it a success. That's techserve.com/Twyett. techserve.com/Twyett, and we thank TechServe for their support of This Week in Enterprise Tech. Let's have one last round from our visitors. Thank you both so very much. Carl, let's start with you. If you were making a case for IPv4, I know that you like IPv6, but if you were to tell someone who was considering how they're going to structure their network, how they're going to structure their 10,000-seat enterprise network, what would you tell them about IPv4, about the bridge and island approach, about why maybe they should consider not putting all their eggs in the IPv6 basket?
Well, I want to first agree with Brandon about that proxies are probably going to slow things down, except that we have experience to the contrary with things like Squid and Akamai and stuff, where getting things closer. If you want to speed up your network experience, bring your DNS to you locally, because DNS is multiplied many times. Delays there are really do reflect on user perceptions more than anything else. As for someone who's deciding whether to go forward with V6 or not, if they're doing a brand new deployment and they haven't spent any money, don't have any already spent capital investment, then V6 would probably be a great way to go, realizing though that there are going to be parts of the internet, large parts of the internet, which they're not going to be able to directly communicate with unless they speak IPv4. And right now, that may be a larger part of the internet than the V6 network. So they're kind of going out on their own there, and they better realize the ramifications of it. They may also want to look at their pocketbook and realize how much money they're going to be spending. For example, my own experience is IPv6 capable printers are more expensive than the IPv4 only ones. So they need to look at more than just the technological considerations of all of this. And that's really my answer.
I like that. So you are violently agreeing with Brandon.
I agree with Brandon most of the time. I consider him a wizard.
Okay, Mr. Wizard, let's go over to you. Same scenario. Someone comes up to you and says, hey, actually, let's take two scenarios, because Carl gave us two scenarios. A guy comes up to you. He has a 10,000-seat enterprise network that he's been running for quite a while. They've done major capital outlay. A lot of it's dual stack, but some of the devices, as Brian brought up, like printers and older devices, still require IPv4. You've got someone else coming to you, and he's got a brand new network that he's setting up, a 10,000-seat network that has not yet been created. What would be your advice to either of those men?
Yeah, sure. So first of all, I want to say what an enormous honor it is to have Carl Auerbach call me a wizard. It's quite the opposite, actually. But so I'll tell you exactly what I do tell them, because in my day-to-day business, this is exactly what we do to help our clients out. And so what we tell them, if you're building a greenfield network, deploy V6 along with it. It doesn't take that much more effort. Are there devices and equipment and software versions that aren't ready, like the printers Carl's talking about? Of course there are. And you just have to do that value judgment when you look at each individual piece of equipment and make those decisions. We don't tend to deploy printers too much, so I don't know a lot about printers. But what I can tell you is that for core networking elements, support is nearly universal across all of the major vendors and really most of the smaller ones as well. Now, how that affects your decisions as you go forward, each business is going to be run a little bit differently. But for example, when we provide our professional services to do a greenfield installation, we just include IPv6 as part of the cost of the project. We don't charge extra for it. It's just there because we think it's the right thing to do. Now, for a non-greenfield network, right, for a network that would have to go through a lot of time and cost to upgrade, don't upgrade. There's no reason to upgrade until that inflection point between the cost of expanding your network with IPv4, because addresses get more expensive, and the cost of replacing your equipment outside of your normal equipment replacement cycle. Until those 2 points meet, yeah, sure, keep what you've got. But you do want to keep an eye on your competition, like I mentioned before, and make sure that you're not missing out on sales and because of performance problems by not having IPv6. But keep in mind, that doesn't mean that you have to do a wholesale replacement of your entire network in order to do it. The printers don't need to be changed. You don't care how long it takes a printer to print something if it's off by a couple seconds. What you care about is your publicly facing website and e-commerce site performing well and being able to reach everyone.
Well, I have to tell both my guests that this has been very disappointing. I was hoping for a brawl for it all. I got an IP love fest, and that's not acceptable. But no, thank you, gentlemen. Thank you so very, very much. I found this informative. I found it fun. I like talking about stuff like this because it does feel ivory tower. It does feel a little bit pie in the sky, but we're using IPv6 right now. We're using IPv4 networks right now. We're using IPv6, IPv4 tunnels. So I think if we're in the enterprise, if we're in networking, this is something we should be paying attention to. I want to first thank Brandon Ross, CEO of I'm sorry, I totally forgot your company, of the Network Utility Force. Why did I forget that? I know that you're down in Columbia. Next time you're going to be in studio because we got to have you here. But here's your time to tell the audience where they should find you. If they like what you said about IPv6, if they want to talk to you more, if they want to maybe ask if you might consult with them, where should they reach you?
Sure, you can see my domain name right there at the bottom of the screen. I don't know if I can get my finger in just the right spot, but you can reach us on our website there, or you can put my 2 initials in front of that with an @ symbol, and you feel free to email me.
Absolutely. There we go. And I do have to say that Brandon is one of the people from Interop that I enjoy spending a lot of time with because he can always show me something. Speaking of someone else who can always show me something, Carl, it is always a pleasure to have you on the show. This is your 3rd time on Twiat, and I don't think the chat room is tired of you yet. That's odd. Normally by the 3rd time they say, yeah, we're done with him. But where can they find you? Where can they find your work? And where could maybe they ask you questions about their own network happenings?
Well, they'll be able to find me physically in Florida next month. I'm going to be at the DARPA Digital Robotics Challenge, where they're taking rescue robots.
Tell us about that, because this is actually an awesome project.
Yeah, it's not my project. I'm just sort of helping out. Robots can go in places where people can't. So DARPA is funding a project, challenge like the self-driving cars, to build rescue robots, first responder robots, to go into fires and other situations where you really don't want humans to go. So this is a live trial. Robots have to go in and they have to go over debris fields, clear debris, attach fire hoses, climb ladders, drive ATVs, all do this sort of stuff. And some of these things look just like Terminator robots. And these are going to be running around, and we're dealing with part of the network there. Our job there, my job there, is to break the network, to add impairments to make it look more like what a real-life network might be during an emergency situation. In other words, noisy, dropping packets, long and variable delays, things like that. That's happening in Florida, Homestead, Florida, the week, I think the 20th and 21st of December, and apparently it's going to be at the Homestead Speedway down there, and it's open to the public to come observe, and I'm going to be around, so probably can chat with me during the whatever free moments I have. Otherwise, I'm in Scotts Valley and Interworking Labs, where we do our testing stuff. And I'm on the net at carl@iwl.com. We're lucky enough we have 2 3-letter domains in .com. And I'm always happy to chat with people. And we're also, of course, doing our History of the Internet series, which we're going out and interviewing lots of people. We just did the Internet Archives the other day, just before the fire. So we're involved in lots of stuff. We're ready to talk to people, and we'd love to chat.
Thanks again, Carl. Always a pleasure. And of course, I have to thank my two co-hosts, Mr. Brian Chi. Brian, I know you've got an off day, so hopefully you're going to enjoy some time in the sun. But you've got a few interesting projects in the making, right?
Well, yes. Actually, I'm going to be working with Ixia Corporation, and we're going to try and create a bunch of, call them cookbooks. One of the complaints we've had from a lot of corporations is that, quote, testing is too hard. So a cookbook gives you the ability to bootstrap your people so that you can start testing easier, faster, better, and so forth. As a mission, we'd like to avoid the Obamacare website problem. My personal soapbox is corporations and organizations don't do anywhere near enough testing. It used to be the fashion before, back in the days when networks don't always work well together, and that's where interop was born. But people have fallen out of the habit, and you get things like Obamacare. So, dear Mr. President, I'll send you a signed copy of my cookbook on how to test websites.
I like that. I don't think Curtis has been working on a cookbook, but you do have a few things going on over at Enterprise Efficiency, right?
Absolutely, Padre. One of the things that we're doing is continuing to try and tell the stories of CIOs and top IT executives, and put out the call to the Twiat Riot. If you are an IT executive, you're a CIO, and you have some interesting stories to tell, or if you'd just like to talk with me about what you're doing, how you're doing it, I would love to have the conversation. You can send me a direct tweet down at KG4GWA, or Franklin at enterpriseefficiency.com will get an email to me. I would love to have a conversation with you.
Thanks, Curtis. Thanks to all of my panelists. Seriously, this show becomes what it is because of the knowledge that you bring in. But of course, the reason why the show exists at all is because of you. Because you come back week after week to watch the best dang enterprise podcast in the world, which, again, you've used up another hour. Go figure. But you know what? We want to do something for you. So what we would like for you to do is to visit our show page at twit.tv/Twiat. There you'll be able to find all the different ways to get the episode downloaded into your device of choice automatically each week. We've got selections for your iPod, for your iPad, for your Android tablet or phone, for pretty much every device you can think of. We're going to give you a way to get all the goodness into your hotness automatically. Also, we've got a YouTube page. If you go to youtube.com/Twiat, you'll be able to find not just all of our episodes, but you'll be able to see all the individual segments that we post. And I swear, eventually we're going to start doing our Hangout series. We're just having trouble finding scheduling time. It's what happens when you've got all these busy people. Also, you can follow me on Twitter at twitter.com/PadreSJ. In fact, there's a good reason to follow me this time because I want to hear from you. I want to know if this is the kind of show that you want to see, if this is the kind of knowledge that you want to hear. Do you want us to bring you the best thing from Carl Auerbach and from Brandon Ross? Do you want us to do more tutorials? Do you want more homework? This is where you can let me know. Twitter.com/PadreSJ. Also, you probably knew, but just in case you don't, let me remind you that we do the show each week live, Monday, noon, Pacific time, here in the Brick House. The reason why you want to watch live, if you at all can, is because you get to see all the things that don't make it into the edited version. Yes, the download is great. I mean, it comes in audio, video, high-quality video. But if you watch live, you get to see how the sausage is made. That means the pre-show. That means the post-show. That means you get to see all the things that I messed up. And believe me, I mess some things up. Also, it's time for the survey. If you've been watching Twit, if you've been enjoying all of our content, we now need your help because we need to know how you enjoy Twit, how you enjoy all of our programming. Go to twit.tv/survey. It's a really short survey. We just need to know what shows you watch, how you watch it, and essentially how you want it to be in the future. It's your way of contributing back to this wonderful creation that is Twit. And speaking of contributing, why not, if you're going to watch us live, jump into our chat room at irc.twit.tv. There you will find some of the brightest people, some of the funniest trolls, and just some really good discussion centered around whatever show is currently on Twit. You may have noticed that I pull from the chat room, and that's because a lot of the inspiration from the show comes from the people in Chat Realm. We are Chat Realm, and Chat Realm loves us. I want to thank Cyberdog in the chat room for helping with the show notes, to everyone here at the Brick House who makes this show possible, especially Karsten and my TD Jason, who, by the way, normally right now I pretend like I don't know what a show is, but Jason, I'm going to say, yeah, you know, you normally do a show called All About Android, which I understand is everything about everything concerning Android, the operating system, devices, and the lifestyle, right?
Yeah, actually, you nailed it.
How about that?
It's as if you've been on the show before.
I know, weird. It's so weird. It's so weird. but tell us, where do we find All About Android, and when should we tune in?
Twit.tv/AAA for All About Android. You can tune in live Tuesday nights, 5 p.m. Pacific, for about 2 hours, and then it posts later that evening, so you can subscribe at twit.tv/AAA. Love to see you there.
That's it from the Brick House for This Week in Enterprise Tech. I'm Father Robert Ballas, reminding you that if you want to know what's going on in the enterprise, just keep quiet.